Okay, welcome everybody. We're going to go ahead and get started. We're 1 minute past the hour. I want to welcome everybody to today's webinar, Best Practices for Using Teleport with Kubernetes and SSH. My name is John Silvers. I'm with Gravitational. And today the presentation will be delivered by Sasha Klazenchas, who's our CTO and one of our co-founders. And the webinar will be about 30-40 minutes of presentation. Please go ahead and submit any questions if you have them into the question panel, Q&A panel. We'll try to get to some of those at the end. We'll try to wrap this up at 45 minutes past the hour. If we don't get to everybody's questions, I think we'll be able to go through them afterwards and reply to people individually, but we'll try to get to some of them on the phone today. And I think that's it. Oh yeah, we are recording this and we will send a link out to everybody after the webinar with the link to the recording. And I think those are all the housekeeping notes I wanted to take, and I'll pass it on to you, Sasha.
Hey, John, do you hear me?
Yes.
Perfect. Hey, everyone, thanks for joining the webinar. Today, as John has mentioned, we will discover not only how Teleport helps to access infrastructure securely with Kubernetes and SSH, but in general, I wanted to give you a little bit of overview of Teleport architecture, basic principles, guiding it. But before that, I want to just give a quick intro of what Gravitational is and what we do. So if you're not familiar with Gravitational and maybe just heard about Teleport, Gravitational deploys and manages complex applications across distributed infrastructure, and there are two products that help us to achieve this goal. One of them is Teleport. We'll be talking about it today. Another one is Gravity. So Gravity is our distribution of Kubernetes. It allows you to package complex microservice-driven applications and deliver them as installable software on customers' infrastructure. We do this by leveraging Kubernetes. In general, our customers are happy that they don't have to worry about deploying on-prem. They just have to make sure their application is multi-cloud and Kubernetes native, and that's pretty much it. But today we're not going to be talking about Gravity. If you're interested, maybe you can express this interest in Gravity by signing up to our Gravity webinar. But in general, today is about Teleport. Teleport, industry standard terminology for Teleport is privileged access management, and that stands for essentially a system of tools or software that allow to segment and control access to distributed infrastructure. And distributed infrastructure, it's a very broad term. It could be as simple as single SSH box somewhere in on-prem scenario, or it could be 10,000 nodes on AWS, or it could be Kubernetes cluster. So everything that fits this terminology could be addressed by privileged access management software. And if we will walk through the webinar, I wanted to explain how Teleport is built. That's how we think about Teleport. We think about it from the first cryptographic principles, and we usually try to set a crypto invariant, some sort of technology, and we try to stick to it and build the system around it. So that's how we generally approach building a security product like Teleport. So in Teleport scenario, public-private key crypto is at the core of everything Teleport does, and everything that includes any sort of authentication or even authorization is based on that guiding principle. So there are no other authentication mechanism that we are generally using, maybe with the notable exceptions where we have to use two-factor authentication, which we will cover later. But that's in general what Teleport uses. So through the course of this webinar, I have a bunch of diagrams for you. I'll also be using this whiteboard. Let me zoom in a little bit. And we're going to be just generally exploring the product. If you have some questions, feel free to submit them. John will process them, and we will leave some time to go through them. Let's zoom in into basics. And we will definitely do some demos, so I promise not to bother you that much with theoretical exploration of cryptography, but I think it's important to highlight that what public key crypto is, in case if you need a refresher. So in general, assume we have an actor user, Alice, and Alice has her identity. And from a cryptographical standpoint, Alice can have multiple identities, and those identities are represented by a pair of keys. So those are cryptographic keys, and they're in classic public-private key crypto. There is a pair of them. So there's private key Alice never shares to outside world, right? Ideally, it should be encrypted, should be secured, maybe stored even on YubiKey or something like that. Another one is public key that Alice can share with the outside world. So this public key could be published on the web, sent to third parties. There is no absolutely harm for sharing it. And I'm sure you're all familiar with that term. So what does that have to do with teleport? Well, if you think about how classic OpenSSH authentication works, so that was one of the first public key crypto authentication method. When Alice establishes a connection, let's say to SSH server, there is definitely an SSH session establishment going on. But in general, in the core of it is the fact that Alice uses her private key to prove her identity to the SSH server. The way she's doing that, she uses her private key to sign a message that is composed of unique session ID. So when we establish a session ID, we generate this unique identifier of this individual session that all parties agree on. And essentially, Alice proves that she possesses the private key by signing this unique.
Hey, Sasa, just to interrupt real quick, could you go full screen on that?
Sure.
For folks who are wanting to be able to read all the slides. There we go, perfect.
Let me do that. I'm actually not sure if I can do that, but let me
we may not be able to do that. Maybe we could zoom in.
Yeah. Let's see. To be honest with you, I'm not that familiar with this diagramming tool, so we can share this after the presentation. So I promise you, there's not that much to read in except the stuff I'm talking about. And we have actually all this data in the white paper. So after the presentation, we can send you all a link to the white paper, and all this information is right there. So you don't need to be afraid that we're missing out on anything by not writing things down, and we'll just go along with the presentation. In general, that's how Alice proves. In this particular scenario, she proves that she possesses the private key by signing this unique session ID. And SSH server can use the public key that has to be distributed before the actual exchange. It has to be distributed through whatever other means. Usually it could be system administrator uploading the public key to authorized keys file, or it could be as simple as there's some automated tool like FreeAPA doing the same thing. Anyways, one way or another, SSH server can actually use the public key it already possesses to verify that Alice signature is indeed correct. That's how SSH server identifies Alice and makes sure that this SSH session is with Alice. Now, there is one specific problem with that, and that's essentially when we go to, let's say, a distributed infrastructure. That's what all teleport is about, where you have thousands of servers and you have hundreds of employees joining, and they may have multiple devices and public keys in every single device. So management of those public keys becomes a problem. And probably some of you have encountered this problem. Let's say usual SSH server, let's say you have 100 employees, every employee maybe have a couple of laptops on average. So you end up with a couple of hundred public keys on every server. Some employees leave the company, some employees lose their keys. So there is a lot of operational complexity, and just generally, there is a problem of managing all those public keys. There is software that's doing that. Again, there is open source software like FreeAPA, but we've been thinking about, and OpenSSH team has been thinking about a better way of managing it. And one of the advancements in crypto technology is not just public keys, but certificate authentication. And in general, if we think about the concept, the underlying concept, whenever Alice uses her certificate, is exactly the same. So behind the scenes is still the same private key. So if we look at this new exchange, where in this scenario, Alice has an SSH certificate, and we'll go to whiteboard to explain how Alice could get an SSH cert. But for now, let's just assume Alice got an SSH certificate from the third party. And this third party could be, your organization, administrative or security team. So now we do introduce a third party in the equation that issues those SSH certificates. At the core of SSH cert is still, if we look at the structure of the SSH certificate, there's still a public key, the same one by design that Alice was using before. But in addition to that, there is a bunch of metadata that is signed by a third-party organization. In this case, could be your security team or administrative team. This metadata is critical because it provides additional information about Alice's identities, this specific identity, crypto identity, such as valid principles. So in SSH terminology, principles is a list of logins on Linux hosts. So it is interpreted this way. So let's say if I got a root or admin in my list of my certificates, in my list of my principles inside the cert, it means that OpenSSH server can look at this metadata and interpret this by saying, okay, you can have root access to this box. That's how important the metadata is. But another really important piece of the certificate, if we zoom in into the cert itself, is actual signature of the cert. So the signature, the certificate is basically, you can think about it as a text file that has a bunch of structured metadata around inside it. And in addition to that, there is a signature, and the signature is by the third party. So this external authority, what's usually called in this scenario certificate authority, that issues this certificate by generating all this, creating all this metadata, and then putting a signature. The signature is extremely important because not only the cert itself can be verified, it contains the public key, it contains the metadata, but the signature makes sure that the metadata in the certificate cannot be tampered with. That's very, very important because, if I was an attacker, I can just, take public key or steal the private key and elevate my privileges. So with OpenSSH certs and other types of certificate, that's impossible because I cannot tamper with metadata. It won't pass the signature test. Anyway, if we'll go back to the exchange, we will see that in general, that's the same. That's the same exchange. Alice still uses her private key to sign a message, still composed of same unique session ID of SSH connection of the cert, and then she sends an authentication request. The server first check the cert is signed by trusted certificate authority. So this step was missing. In this case, actually, certificate doesn't, OpenSSH server or a teleport server in this scenario doesn't actually care as much as about individual public key. So it doesn't actually have to store the public key of Alice or many other her coworkers with different crypto identities. The only thing that in this scenario, a server has to make sure that it trusts the signature of the external authority. It's really, really important because it makes a huge difference. It means that once OpenSSH server or teleport server trusts the external authority, it doesn't have to bookkeep all public keys. And it simplifies on a distributed infrastructure, it simplifies verification of identities, because the only thing we have to care about is the certificate of the certificate authority, essentially, not the individual public keys. An individual certificate, we don't have to store them on every server, and so on. So the server verifies that the cert has not expired. That's another important thing. Remember, in our metadata, if we look at the different extensions, there is valid after and valid before field. So when we're issuing a certificate, that's another important thing that is inside the cert, is that we put expiration date in the cert. And it could be as short as 1 minute. It could be like even shorter if we would like to. It could be long, like 10 hours. When I've been talking to industry experts in the field when building out Teleport, they've been in large organizations such as Google and Facebook. They've been all mentioning different practices around this sort. Some certificates and some organizations using more aggressive expiration. Some are using a little bit more lax, like 10-hour expiration. But what's important here, let's say if Alice loses her laptop, after 10 hours, this certificate will not be valid and it cannot be used, because whenever anyone can steal Alice's laptop, authenticate, maybe root it, and then use her private key, 10 hours later, it won't be valid because it won't pass authentication. It will be expired. That's another important feature of OpenSSH certificate authentication. It's not specific to OpenSSH certs. As we will look later today, it is also specific to Kubernetes as well. But that's another important thing to keep in mind. So if all those checks are passed, server assumes that this is Alice cert and public keys are trusted, verifies the signature, say it's sent by Alice, based on the session ID. So you see the first step, even before verifying the signature, is verifying the cert itself. And if the signature matches, the server accepts the auth request. That's as simple as that. And then I don't want to bother you with more details about the public-private key crypto. If you have some questions about that, feel free to ask them in chat, and after John will collect them and send them to me. But I wanted to jump into the actual practical demonstration, and I wanted to share my screen real quick. And let me know if you'll see my screen in a moment. That's my whole desktop. So here we go. How does this all translate to Teleport, and why I was talking about all this stuff? Now let's talk about Teleport and how Teleport implements this. We have this tool called TSH, and TSH can work on any laptop. It's a very small helper tool. It can work on Mac OS, Windows, Linux, and behind the scenes, we've been thinking about how would your working day look like, right? If you're an employee of the company, what would be the easiest way for you to start your working day? And we couldn't imagine anything simpler than just logging into your SSO of your organization once. TSH helps with that. If you look at this, we just do TSH login command. And what will happen in a moment, my browser will open an SSO of my organization. So Gravitational uses GitHub, and probably many of you as well. It doesn't have to be GitHub. It could be something else. So if you're not familiar with the terminology of SSO, it's a single sign-on. It means that there's a special protocol called SAML or OpenID Connect that I can use to authenticate myself. So what happens here, I'm entering my credentials, and I'm logging through my single sign-on, right? And that's pretty much it. So TSH, what happened behind the scenes, and I can demonstrate this to you on the whiteboard diagram. Let's go here real quick. So my TSH tool started an SSO process. And I won't be digging too deep into SSO, but we can think it opens a browser and delegates the flow to my identity provider. So it trusts my browser and my laptop. It assumes that it could be a trusted medium of exchange. And it forwards this to identity provider. It could be Google, could be GitHub, could be Auth0, or Microsoft ADFS. It doesn't really matter. So in this case, from there, the actual provider takes care of exchange with me, just as it asks me for my credentials. It uses my username, password, whatever is relevant. Another important piece is Teleport in this scenario doesn't actually govern your authentication policies. So different organizations have very different ideas what sort of second factor authentication to use, what password policy to use, what is the expiration. So instead of using Teleport to define all those, it's much better to let provider define the policies and your organization define the policies, how long the session should be. All this is delegated to identity provider. Once identity provider is happy with your credentials, it sends the approval request back to TSH. So there's an interesting exchange going on between the browser, identity provider, and your local host. And TSH in this scenario just listens for this exchange, if that makes sense. Anyways, at the end of all this, what's really important, and there's always a lot of complexity, accidental or not, in different infrastructure software. But that's why I was talking about crypto underlying concepts. At the end of all this, we always get a certificate. So our private key, we get a public key pair, public-private key pair, and we ask essentially Teleport in this exchange when we're doing certificate, when we're doing authentication. When we're doing this, we're asking Teleport to sign our public key. If identity provider authenticates us. So as you can imagine, there's Teleport proxy somewhere here hidden. You don't see it in the exchange, but it's present, and it's something set up on your infrastructure, so it's not a hosted software. So in this scenario, if Teleport observes this requests exchange between TSH and identity provider, it makes sure that this exchange is valid, and in this scenario, it actually signs the public key of my corresponding to my private key. So in this particular exchange, I always get a cert once a day or I can get a certificate faster than that, depending on my requirements and my infrastructure requirements and my security practices. If we look at, now we understand the metadata concept of the certificate. This is exactly what you would see. That's the metadata about your current certificate that we're showing after the successful login. So in this scenario, I'm logged in, it's my identity, it's my email associated with GitHub, it's the cluster. We can talk about clusters on more advanced webinars, but we don't have to worry about that. There are a bunch of roles, which essentially is a metadata encoded in the certificate. There are principals that we are familiar with already. So those are principals encoded in the OpenSSH cert. Those are the same. And it mentions that I'm an admin in this infrastructure, in this demo infra, so I can log in as root. And it's also valid until, so it has certificate parameters. So it's valid for 12 hours, and that will expire after that. And in addition to that, there's a bunch of OpenSSH permissions. So I'm allowed to do agent forwarding, port forwarding, and in general can have interactive access. But you can imagine, based on my identity provider and organization policies, I can, for example, disable interactive access if I'm issuing a certificate for Jenkins, for example, which doesn't actually have to do login interactively anywhere. All right, so what do I do with this cert, where the cert is located? If we geek out a little bit and just go here, keys, we will find actually all the certificates right here. So this is my private key, this is my certificate, this is my public key, and this is my cert that has been issued for me. In addition to that, but I don't actually have to have access to them. However, if I would like to, I can reuse the same private keys and certificates with OpenSSH. That's another cool thing with Teleport. It actually does not implement its own protocol for server access. It is fully OpenSSH compatible. But TSH, you can use OpenSSH, but for the demo purposes, I will use TSH. TSH is sort of gravitational Swiss Army knife that allows us to simplify access to distributed infrastructure. And one of the things that OpenSSH does not do for us is discoverability. So discoverability is another advanced feature that usually is important for distributed infrastructure. I would not only like to have access to individual servers, I would like to understand and get more information about those servers. And that's how TSH and Teleport helps us on top of OpenSSH. But for now, let's assume that TSH just provides us the way to access this infrastructure, look at all the clusters. So I have a couple of nodes set up for this demo environment. And I'd like to log in one of them. There's nothing out of the ordinary, it's very simple, but what happened behind the scenes is this OpenSSH-driven certificate exchange, a certificate-based authentication flow between my client that just received the cert and the target server. So that is the underlying guiding principle of Teleport. When we're thinking about authentication methods that are used in the infrastructure, we're always sticking to this principle, right? Whenever you log into the cluster, there's always very specific authentication and crypto going on, which is based on certificates. So I have logged in, and it could be the end of it, but on a distributed infrastructure, another important concept, as I mentioned, is observability and discoverability. So discoverability is just an ability to understand the state of your infrastructure, and Teleport achieves this by having this concept of labels. So whenever Teleport nodes join the cluster, it could be OpenSSH nodes in the cluster, or it could be Teleport nodes, which is a replacement for OpenSSH, or it could be complementary to OpenSSH, depending on how you deploy it. And in general, what we think about when Teleport nodes start up and join the cluster, they could heartbeat information back about this infrastructure and encode this information in the labels. So in this scenario, they could encode some static information about the particular node. So in this, we can see this is environment demo, and it has uptime of 1 week, 6 days. In general, it could be static info and dynamic info. So as you can imagine, uptime and kernel parameters installed on this machine could change, and the Teleport will definitely update this. That will show up in the list of nodes. Observability, that's another thing. Observability allows us as system administrators of the cluster to understand what's going on in the cluster at this given moment. And not only is that helpful for general security inside your organization, it's also helpful from the standpoint of different certifications. There's definitely compliance requirements like FedRAMP that mandate you to be able to terminate the session and block the user and observe everything that's going on and record it in tamper-proof log storage. So Teleport allows us to do this in a very, very advanced way, in a very detailed way. Not only I can observe, if I have permissions, because I don't like this session, I'm terminating it, and that's what the users see here as well. So that's a very, I would say, risky feature. I don't recommend turning that for everyone in your organization. Ideally, that should be only available to super admins, but that's helpful to have. Not only that, but after the fact, you can actually observe and review everything that happened, every single exchange, or maybe situation arises when you have to do security audit. And in my experience, if you don't have centralized logs that contain everything that ever happened with the cluster, it could be a problem, because every security investigation requires you to collect every single piece of logs that happened on your infrastructure and deliver them to security team for investigation. Teleport makes it very easy because all the logs are always stored in tamper-proof storage. And for example, in Amazon, it could be encrypted S3 buckets that are FedRAMP and FIPS compatible. On other clouds, it could be also used in their storage. On-prem, it could be encrypted disk that also has the same properties. So that allows us to have this precedent view in what's happened with the cluster, and also make sure that Teleport makes our infrastructure compliant to FedRAMP, PCI, or any other compliance requirements out there. We do have a white paper coming that explains how Teleport makes it possible to comply with different requirements, compliance frameworks. For example, FedRAMP. We do list exact controls that Teleport provides. So if you're interested in one of those, feel free to reach out to us. We can share the draft with you, but it should be out in a couple of weeks. So John will be happy to share them, to share it with you if you are interested. So that's enough, I think, information about SSH. And our webinar was mentioning not only SSH, but Kubernetes. So that's the cool thing about crypto in general, right? It's such a powerful technology. If done right, it can solve not one problem, but many problems. And when we've been thinking about how can we improve our Kubernetes experience, we were thinking about from the same guiding principles that helped us to build Teleport. So if we use this concept of this certificate authentication, could we apply this concept that works so well on a distributed infrastructure for SSH to Kubernetes as well? Well, luckily, the answer is yes, because Kubernetes was built by Google, who are definitely infrastructure experts, and they made it easy for us to integrate Teleport with their system and make it easy to use essentially the same flow that we demonstrated with OpenSH. So let me demonstrate how it actually works. I do have kubectl installed, and there's nothing specific about my kubectl usage. You see, I'm just using kubectl right out of the box after I have logged in. And I got a magical access to this infrastructure through kubectl. I can also do, if you are not familiar with exactly what kubectl is, so kubectl is a client to Kubernetes. So it's a tool similar to OpenSSH. If you think about OpenSSH, there's SSH tool that allows you to have access to your SSH node. There's kubectl tool that allows you to get access to Kubernetes node, Kubernetes cluster. So Kubernetes operates on the terms of clusters, and you definitely can look at the node, but there's no such concept of getting access to node. However, there is a pattern of accessing individual containers running inside Kubernetes. And I'm not going to be going too detailed on the implementation of Kubernetes and this terminology, but let's just assume if we go to the whiteboard, we have the same problem. We have our user, Alice, and Alice needs to get access to Kubernetes cluster. And for the purposes of this webinar, we have a bunch of containers running in this Kubernetes cluster. By the way, if you would be interested in learning more about this, we do have a series of open source workshops called Kubernetes 101, Docker 101 that explain all these concepts in more detail. But for now, Alice should use kubectl to access this infrastructure. So what authentication mechanism Alice could use, and what SSO flow Alice could use, and how could it all work? Well, the answer is easy. We already actually demonstrated the same thing. So just like TSH signed a public key of our SSH private key, the same actually happened behind the scenes with kubectl. So when we've done TSH login, not only we received identities of OpenSSH, in addition to that, we have received identities of Kubernetes, kubectl. Because kubectl is just a client, it could use different certificates. They're called X509 certs. And those are the same certificates that we're using right now in our presentation. You see there's HTTPS, and in this scenario, Lucid chart on my demo is an HTTPS server that presents, that uses an encrypted connection, and it's behind the scene, it's using the same certificates that you could use with your Kubernetes cluster. So if you can imagine the same exchange going on where you can present your certificate, client cert, X509 cert, to the Kubernetes cluster can verify your identity. And as easy as that. It could be also having the same properties. And but let me demonstrate how it actually works in practice. So I'm execing into the pod. It means that using my client, I'm jumping into the container that's running this specific process. And I'm executing some interactive commands. It looks very, very similar to OpenSSH. However, it's not actually an OpenSSH. There's no SSH going on. It's just a very specific protocol to Kubernetes that they have implemented. But it definitely allows you to have non-interactive and interactive access to Kubernetes pods. It even considered to be anti-pattern, but because it's there, and organizations sometimes provide this feature, Teleport had the same problem. How do we guard access to this infrastructure? And what happens if I do exactly the same actions and by the compliance standards I have to do the same thing? Well, Teleport solves this problem in a very similar fashion. Teleport, when enabled, allows you not to differentiate between your interactive sessions or non-interactive sessions. It captures the output in the same way as it does for Kubernetes. It intercepts your flow. It uses the same client sort authentication. It's really important because never in my demo of usage of Kubernetes, there was no mention of any specific toolchain. Just as we're thinking about all the users of all these infrastructures, how would they want to start their day? What would be the best flow for them? We think of the least amount of friction we would introduce it in their working flows. So if they log in once a day, they can just use their kubectls as usual, and there's no teleport that is presented to them. They don't even need to think about using some external tools or authentication techniques. They can just use their kubectl, and Teleport takes care of the rest. The way Teleport does this, it acts as a proxy between all requests that are happening in the cluster. So if we go to our whiteboard, when Alice executes this request, there's actually teleport that intercepts this request, observes it, authenticates it using the same principles, and forwards it to Kubernetes cluster. Kubernetes cluster, in its term, does exactly the same action. So Kubernetes cluster does not necessarily know that this is Alice going through teleport proxy. So it's a little bit more complicated on the Kubernetes cluster integration, but that's the underlying principle that guides us in building the system. I wanted to kind of dig a little bit deeper. Once we log in, there's no magic. TSH basically updates your kubeconfig if you're familiar with this. So that this particular file is not teleport specific or gravitational specific. It's a Kubernetes specific file. It's your kubeconfig, so it holds configuration for this kubectl tool, and it contains a bunch of stuff. So it contains a bunch of pointers to the cluster. In this scenario, you can see we're pointing to teleport proxy that in its term forwards everything to Kubernetes cluster. In addition to that, it encodes this client server data. So if we look at this client server data, and decode it, this is how the certificate looks like. So it's a basic X509 cert. I like to decode it. Those are just OpenSSL toolchain that helps me to look inside of it. But I would like to zoom in and understand what's actually inside the cert. So inside the certificate, it says, by its design, actually OpenSSH certs are a simplified version of X509 certs. So when OpenSSH team was building their certs, they didn't like X509 because it looked too complex for them, which makes sense because they had to make sure that OpenSSH is portable and works on all these devices, so they didn't want to overcomplicate things. But that's why OpenSSH certs are designed after X509 certs, and that's why they have exactly the same structure. So you can think of X509 as a more advanced kind of web-ready version of OpenSSH certificate. It means that there's public key encoded in there, and you can see there's RSA public key 2048-bit which is actually important because we have to be FedRAMP compliant. That's why we picked that specific one. And in addition to that, there's a whole bunch of metadata we can observe. So there is validity encoded in the cert. It uses the same principles. It uses the same security practices defined by your identity provider. So this validity is actually taking from the policies defined, let's say, on your Auth0 or Azure ADFS Active Directory provider. So for every user, for every group, you can define how long would you want the certificates to be valid. In addition to that, just like OpenSSH certificates encode different metadata that allows you not only to identify yourself, but also provide information about your authorization and security traits. So those security traits, essentially in Kubernetes world, are Kubernetes groups. So we're not going to be diving too deep in this one-on-one webinar presentation, but you can think of them. They're security traits that allow you to identify you as cluster admin. It's a metadata encoded in X509 certificates. And whenever we access this infrastructure, and Kubernetes infrastructure, Kubernetes cluster can look at this crypto sign metadata, verify a signature to make sure it hasn't been tampered with, and based on this metadata, identify what kind of permissions this particular user has on this infrastructure. So that's important actually to make sure that that allows you to have this, what we call late binding of your security for every single cluster, of your security traits or your security properties of every individual identity. It means that, for example, cluster admin is something that is encoded in my cert, but the way it's interpreted by every single Kubernetes cluster could be different. So on one cluster admin could mean that I have full unrestricted access. On another cluster admin could be interpreted as something else. So that's another important concept. But I don't want to spend too much time about this. This is a little bit more advanced. If you have some questions about that, let me know. But actually, I wanted to wrap up and let you all ask me questions. John, if you have collected any questions, or maybe you have questions, just feel free to type them in, and we can go through them. Thank you very much, and hope you liked the presentation. If you have any feedback, let me know.